Distance time graphs show how the distance from a start point changes over time. This graph shows the distance a car travels from a start point over a period of 10 seconds. Each line is labelled A, B and C. Line A shows the car moving away from its starting point at a constant speed, so the distance increases over time. The car's speed is equal to the gradient of the graph. The car moves 20 metres in 2 seconds, so the gradient can be found by dividing the 20 metres by 2 seconds, which equals 10 metres per second. The car's speed is 10 metres per second. Line B shows the car is stationary. It is a constant distance from the start point, so the line on the graph is flat. Line C shows the car moving off again, but you can see it is different to the initial movement of the car. It's still moving away from its start point, but it's moving faster than before. How can we tell this? Well, the line has a steeper gradient, meaning we are moving further in less or the same time. The gradient this time is 30 metres divided by 1 second, which is of course 30 metres per second. This chart, however, has a curved line. Now, what does that tell us? This graph represents a rocket and it's accelerating. That's to say its velocity is increasing over time. This can be seen by the increasing gradient. Now, velocity time graphs, they show how the speed or velocity of an object changes with time. This time the gradient is equal to the acceleration. The area under the graph is equal to the distance travelled. This is because you're multiplying velocity by time. And when velocity in metres per second is multiplied by time in seconds, the seconds cancel out or leave just metres or distance. This velocity time graph represents a car travelling at a steady speed of 5 metres per second. The gradient is 0, so the acceleration is 0 metres per second squared. The area under the graph is 5 metres per second multiplied by 8 seconds, which equals 40 metres. So the car has travelled a total distance of 40 metres. This graph represents a more complicated motion. From the origin to point A, the acceleration is 10 metres per second divided by 2 seconds, which is 5 metres per second squared. The distance travelled is 10 metres multiplied by 2 seconds divided by 2. We have to divide by 2 now, as the area under is a triangle. So the actual area is 1/2 the base times the height. From point A to point B, the acceleration is 0. From point A to point B, the acceleration is 0. The distance travelled is 10 metres per second multiplied by 2 seconds, which equals 20 metres. From B to C, the acceleration is 20 metres per second divided by 2.5 seconds, equaling 8 metres per second squared. The distance can be calculated by dividing the area under the line into a rectangle and a triangle, calculating the areas of each and adding them together. We therefore see that it's 10 metres per second multiplied by 2.5 and 20 metres per second multiplied by 2.5 but divided by 2. Add those two together and that gives us a total distance the car travels of 50 metres. Now from C to D the gradient is negative, which means the acceleration is negative and thus the car is slowing down or decelerating. The total distance travelled is 80 metres. In summary then, on a distance time graph, a flat line indicates the object is stationary. The steeper the line, the faster the object is moving. On a velocity time graph, the gradient is equal to the acceleration, and the area under the graph is equal to the distance travelled. In the next video, we'll start to look at how forces combine. Make sure you subscribe to our channel, click the bell to receive updates as and when we upload more videos. And until then, keep wondering about the universe.